Hi there, welcome back to another video with the Math Doc. We are continuing to talk about functions and their domain and range. If you're new to this channel or you haven't seen the previous two videos on functions, please check them out. They're in the same playlist. And let's get started. So we discussed the definition of a function and domain and range in the previous two videos. Here, I would like to highlight one detail of the definition of a function that I didn't discuss in too much because we were getting just, first of all, the general idea of what a function is. But in this definition here, you see a function is a relation that pairs each input with exactly one output. And this is important. So now we're going to focus on this exactly one output. The point is that if we had said that we have this machinery called a function, right? Illustrated here with this little machine. And that machine gets inputs that are from the domain and generates outputs that are part of the range of the function. And we used two main examples. We talked about the price of peaches, right? We said the price of peaches equals 2 times the number of pounds we're buying. And so if we had the input, say 1, 2, 3 pounds, these had outputs of 2, 4, and 6, right? So 1 pound is $2, 2 pounds are $4, and 3 pounds are $6. And that is our function, that relation between the domain of inputs and the range of outputs is the definition of our function. We also showed we could present that function with a graph, right? Here, if we have here x is the pounds and y is the price, this is our function, right? So if we have 1 pound, we pay $2. If we want to buy 5 pounds, we pay $10, right? You can see that in this graph. We also looked at a slightly more complicated example, and that was the pricing of parking in a parking lot, where we said, in this case, the first hour is free. So the first hour here, X is time that we spend in the parking lot, and this Y again is our fee, right? How much we pay. In this case, it's something called a step function, where for the first hour or any fraction of it we don't pay. The first hour is free. Then for anything starting with this in the second hour, from an hour and 1 second to 2 hours, we pay $1, and so on. And in this case, I guess we could look at half hour, 1 hour, 3/2 hour, and in this case, we have for that first half hour, we have 0. For our first hour there, again 0. And then for 3.5 hours, we pay $1. For 4/5 of an hour, we also pay $1, and so on. So in this case, we have for various different x's the same y. So in this case, we can have, and I'll write that out symbolically, say x1, x2, x3, all going to y1. Okay? So that is okay for a function. The reverse of that is not okay. So what do we mean the reverse? Well, if we were to go into a market and try to buy 2 pounds of peaches, we expect to have only one price. We can't have 2 pounds of peaches cost $4 or $6. That is not consistent. So for that reason, a function is defined so that every input has exactly one output. So let's look at a couple of examples that are not functions, so you get an idea of what that means. For instance, if we present a function f with some ordered pairs, let's say x, y, right? These are ordered pairs, and let's say our ordered pairs are 1, 7, 3, 6, 4, 2, and 3, 9. As you can see, let's highlight that in a different color. We have two ordered pairs that have the same x, right? They have the same x equals 3, but we have two different y's. We have y's equals 6 or 9. So this means that this is not a function. Not a function. Okay? It's helpful to remember that we always want to have a determined output for what we put in our machinery, in our function. Look at another example. For instance, let's look at an example that we identify through a curve. Let's say we have here the x-axis and the y-axis, and let's look at this curve. Now this curve looks like it could be a function, but we can apply a certain test that we call the vertical line test. What is the vertical line test? Well, what we do is we draw a vertical line through various parts of our curve. And what we see here is that for this x, let's call it x1, we have three different values of y. We have y1 here, y2 in the middle, and y3 at top. So the same x1 has an ordered pair at y1, x1, y2, and x1, y3. So we have same x with multiple y. So again, this is not a function. Not a function. Let's look at another example. For instance, again, another curve that might be interesting. Let's draw a circle in the xy plane. So again, we have x and y, and every one of these points here can be symbolized by a ordered pair. Let's put our vertical line here. Again, we'll call this x1. And again, our vertical line cuts our curve, our graph, at 2 points. So again, we have two ordered pairs with the same x, but with a different y. So this is not a function. Let's look at one more example, and let's look at an example where we actually do have a function, just to remind ourselves of how we would do that. So let's look again at the xy axis. If we draw something called a parabola like this, we can see that for every vertical line that we pass through this curve, we only have one y for each x. So for x1, we have y1. For x2, we have y2, and so on. We do have, this for the same y, we will have two different x's, but that is okay, because again, we can have x1 go to y1 and x2 go to y1 as well. This is a function just like for the case of a parking fee, where we have for half an hour and for 3/4 of an hour the same fee. So we will work more with the domain and range of functions, and we'll do more examples. If this video was helpful, please like. If you have questions or comment, please include those below. I'll be happy to respond. Thank you for joining me again for another video with the Math Doc. I hope to see you again in our next video.